Perimeters of similar polygons. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. Now, what that means essentially is that once you find the scale factor, for example, if we take KLMN and we dilate it to get to PQRS and we find that scale factor, the scale factor from each side is the same thing, which is also true for the perimeters. So the way we write that is we're going to say if KLMN is similar to PQRS, then, and I'm going to need more space, so I'm going to hop down here. The ratio of side KL over PQ is equal to the ratio of LM over QR, which is equal to MN over RS, which is equal to NK over SP. That is your statement of proportionality. The side over the side equals the side over the side, etc. But that's also equal to the perimeters. So then I'm going to take KL plus LM plus MN plus NK, because remember perimeter means add up all the sides. So I added this one, this one, this one, and this one over the ratio of PQ plus QR plus RS plus SP. So we took this one plus this one plus this one plus this one, and then those are also equal. Areas of similar polygons. If two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So this time we're not talking about perimeter, we're talking about area, and it says the squares. So if KLMN is similar to PQRS, then this time we're going to be talking about the areas. So I'm going to start with area of KLMN over the ratio of the area of PQRS is equal to. Now, my statement of proportionality is going to say that side KL over PQ. But when you do area, isn't area like units squared? You know, it's like inches squared or something squared, feet squared, versus side length is just inches. Well, right now these don't match because the area one is in square units and the side length is in regular units. So we take this and we square it, which is then also equal to the ratio of LM to QR. But again, because those are side lengths, you have to square it, which is equal to MN over RS squared, which is equal to NK over SP. And you have to square it. Example 4. A town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. The new pool will be similar in shape to an Olympic pool, but will have the length of 40 meters. Find the perimeters of an Olympic pool and the new pool. So I'm going to start with Olympic and new, and I'm going to draw our Olympic pool. Now, they told us that the Olympic pool is rectangular with a length of 50 meters and a width of 25. Then it told us that the new pool is similar, that's a key word, and it has a length of 40 meters. And it wants us to find the perimeters of the Olympic and the new pool. Well, at the moment, the Olympic pool, we can find the perimeter. We just have to add up all the sides. So we would take 50 plus 50 plus 25 plus 25. So that's going to give us a perimeter of 150 meters. Now, in order to find the perimeter of the new pool, we're missing a side. There's a couple ways to find it. Most of the time, I'm looking at the ratio of the Olympic pool, which says this is 50, this is 25. So in order to get from 50 to 25, I can cut it in half. So in order to get from 40 to whatever should be sitting here, we're going to cut it in half, which is going to give us 20. Then if I find the perimeter, I'm going to take 40 plus 40 plus 20 plus 20. That's 8, 9, 10, 11, 12. So my perimeter is 120 meters. Now, we have officially answered the question, but what I want to look at here is that rule that we just went over. So if I take the perimeter of my new pool to the perimeter of my Olympic pool, that's going to give me a ratio of 120 over 150. Well, that's the ratio of the perimeters. But what about the ratio of the side lengths? Well, I could take 40 over 50, and I could take 20 over 25. And let's see what happens. If we simplify 120 over 15, we're going to get 5 over 4. Well, what if we simplify 40 over 50? Well, I think I did something backwards. Oh, sorry, that's not 5 over 4. That's 4 over 5. My bad. Okay, so if we simplify 40 over 50, that's also going to get us 4 over 5. And if we simplify 20 over 25, that's going to get us 4 over 5. So do you notice that the ratio of the perimeters is equal to the ratio of the side lengths?